Hey guys, welcome back to our science experiment for today. Now yesterday we made our charts and we also went over the definitions of the different physical properties that you can measure when classifying an object. And today we're going to be classifying objects based on their physical properties. We have 5 objects I'm going to be doing today. We have a toy car, a paperweight, a ruler, an ice cube, and finally, this glass of water. Now, really quick, the 4 physical properties we'll be measuring today are texture, state of matter, flexibility, and temperature. Now, let's start off with the toy car. Remember, texture, which is our first physical property we're cataloging, is how something feels. How does it feel when you touch it? This car, it doesn't feel rough, it doesn't feel fuzzy, it feels really smooth, so I'm gonna write smooth. And next, state of matter. Remember, solids have a constant shape and a constant volume. When I set this car in my hand or on the table, it doesn't get any bigger and it doesn't change its shape. That means it's a solid. And next, we'll be doing flexibility. How bendable is this car? Well, you can see I'm pressing on it and it is not bending. That means it is rigid. Remember, rigid? That means something is not flexible. It cannot bend. Lastly, we'll be measuring the car's temperature. Now, the car is not cold and the car is not hot. We're gonna say when it feels normal, that's called room temperature. So we're gonna write room temperature. Next, we're gonna be measuring our cup of water. Now, the water feels wet, is how I would describe it. So we're gonna write wet. Next, let's look at this. The state of matter is liquid because it has a constant volume, but it changes its shape based on its container. That means it's a liquid. As far as flexibility goes, I don't know about you guys, but this water looks pretty flexible. Looks like it'll fill the shape of any container it goes in. So we're gonna say it's flexible. Lastly, we're gonna measure the water's temperature. Now, I don't have a thermometer, and I know you can't feel it, but when I put my finger in here, this water is warm, so we're gonna write warm. Next, we're gonna measure the piece of ice. Now, this ice has been sitting out for a couple minutes, and I'm already holding it. It feels really wet and really slippery. So we're gonna write wet and slippery. Next, state of matter. Well, the ice, even though it's wet and it's starting to melt, it has not changed its shape and it's not changing its volume. Both are constant. That means it's a solid. Next, flexibility. Now, this ice, maybe if it was thin enough, it'd break, but it's not bending. That means it's rigid, which means it is not flexible. Lastly, the temperature. Well, it's ice, so it's pretty cold, so I'm gonna write cold. Next, we have our ruler. Now, this ruler feels really smooth. It's made of metal. Next, as far as the state of matter goes, well, I hold the ruler in my hand, it doesn't change shape and it doesn't change volume. That means it's a solid. Next, flexibility. Well, look at that. I'm bending it, and it's bending, and it's going back. That means it is flexible. Next, well, this ruler is not hot and it's not cold, so we're gonna write room temperature. All right, last object. This paperweight, it's a pyramid. This pyramid is pointy and it's smooth, so we're gonna write smooth. Next, state of matter. I hold the pyramid in my hand. It's not changing shape and it's not changing volume. That means it's a solid. Next, well, it's not bending. That means it's rigid. And finally, this pyramid's not hot and it's not cold. That means it's room temperature. All right, we have filled out our whole table and we have all of the physical properties measured of our 5 objects. Now, I want you guys to break into your table groups and get your buckets, and we're gonna identify all the physical properties as a group in your individual groups.